everybody! In this video we're going to be talking about how to add and subtract functions. This is called function addition and subtraction. But before we get into doing it abstractly, I want to start out with a really simple example. So here's the setup. We have two people, Annie and Bob. Annie can pick 4 pumpkins per hour, and Bob can pick 3 pumpkins per hour. Together, how many pumpkins can they pick in 5 hours? So this is a pretty easy question, and there are sort of 2 different approaches that we can take. So first, we could say that they pick 4 plus 3 or 7 pumpkins per hour together. Which means that in 5 hours they pick 7 times 5 equals 35 pumpkins. So we sort of added up their rates first, and then we multiplied that by the time. So a way you could think about this is that Annie, her function is that she picks 4 pumpkins per hour, where t is measured in hours. And Bob, per hour, he picks 3 pumpkins per hour. So 3 times t is the number of pumpkins he's picked in t hours. So then we said that together, Annie's pumpkin function plus Bob's pumpkin function is 4t plus 3t, which is 7t. So then when t equals 5, this gives us 35 pumpkins. Another way you could think about this is that after 5 hours, well, Annie has picked how many? She's picked 20. And Bob, he's only picked 15. So this is like saying Annie at 5 equals 20, and Bob at 5 equals 15, and so we just added them. A of 5 plus B of 5 equals 35 altogether. So these are 2 different approaches, but we get the exact same answer. We're thinking about it in pretty much the same way. So now let's move into a more abstract setting. Let's do a couple examples. So here we have a function f of x equals 2x plus 3. If you wanted to, keep thinking in our last example, this could be a new function for how many pumpkins Annie can pick after x hours. And this is another function. Maybe this is how many Bob picks in x hours. So then we want to know, what is f of 1 plus g of 1? Well, we can go back to our old way of evaluating functions. F of 1, we just plug 1 into the function. So we get 2 times 1 plus 3. That's f of 1. G of 1 is 4 times 1 squared minus 2. So what do we get here? 2 times 1 plus 3 is 5. 4 times 1 minus 2 is 2. So we add them together, and we get 7. Now, f of x plus g of x, this one's even easier because we're not plugging anything in for x, we're just leaving it as x. So what do? Here's f of x, 2x plus 3. And g of x is 4x squared minus 2. So maybe we want to rearrange things, combine like terms. So we get 4x squared plus 2x plus 1. So this is adding functions. We've added the function f of x plus g of x. F of x was this function. G of x was this quadratic function. We get a new function. It happens to be quadratic. Let's do another example before we move on to our definitions. So now I'm using a new notation, f plus g of x. All this means is what's the new function obtained when I add f of x to g of x. So here all we do is we add f of x to g of x. This is the f of x part, and this is the g of x part. And that gives us a brand new function. This one's cubic. From two functions, f and g, we got a third function called f plus g. So what's f plus g of 2? Well, we just plug in 2. 2 cubed plus 3 times 2 squared minus 5. And what does that end up being? 8. Oops, let me scroll so you can see what I'm writing. 8 plus 12 minus 5. Right? All right. So what do we get? I think that's 15. Another way we could do this is, since we're just adding the functions, we could plug into Annie's function first, plug into Bob's function second, and add them together. So f of 2 is 2 cubed, so that's 8, plus g of 2 is 3 times 2 squared minus 5, and we get the exact same thing. We get 15 again. So now let's make a definition. This seems easy. That's because it is. Don't worry. If you're thinking that this is easy, you should. It's not hard. So the function f plus g of x, it's a new function, is simply f of x plus g of x. All we do is we add the two functions together and we get a brand new function. We just give it a name, f plus g of x. Similarly, if we wanted to do f minus g of x, that's a new function. And that's just going to be, can you guess? F of x minus g of x. Just subtract the two functions. So let's practice. F minus g of x here, if f is 5x squared plus 1 and g is 1 minus x, well, I just subtract g of x from f of x. So here's the f of x part, here's the g of x part. If I want to know f minus g of 1, then I just plug in. So 5 plus 1 minus 1 equals 5. You could also do it this way. Plug into Annie's function first. F of 1 is 6. G of 1 is 1. So 6 minus 1 is 5. We get the same thing. So I could also ask you to think about how the domain changes, because this is a new function, right? So what should the domain be? Let's do a couple examples first. So here we have f of x is 1 over x minus 2. G of x is x squared. So if I find f plus g of x, that's just going to be 1 over x minus 2 plus x squared. So what's the domain of this function? Well, the domain of this function is x not equal to 2. Could we see that from the functions that we started with? Well, let's change to a different color here. The domain of this one, the domain of f is x not equal to 2. Domain of g is all real numbers. So it ended up being the same as the domain of f. The restriction on f held for the restriction once we added them together. So the rule for finding domains of a sum or difference of functions is that the domain of f plus or minus g of x is the intersection of the domain of f with the domain of g. So you could think of this like you're having two friends over for dinner. One friend is vegetarian and one friend is gluten-free. So you need to make a meal that's both vegetarian, can't have meat, and gluten-free. You need to use the restrictions from both of your friends. So you need to use the restriction from f and the restriction from g when you're looking for what is the restriction for the sum of the functions. What's the restriction on the whole dinner when you're inviting both of your friends? Maybe that helps you to think about it. Let's do another example. So here we have f of x is x squared minus 1 over x. So we know that the domain of f is x does not equal 0 because we've got this x in the denominator. For g, we also have x does not equal 0. So by this definition above, the domain of f plus g should be x not equal to 0. This is the restriction on f. It happens to be the same restriction on g, so we have x does not equal 0, the set of values for x where x is not 0. But have a look at this. If we do f plus g of x, we get x squared minus 1 over x plus 1 over x plus x. Let's scroll down again. This function, the 1 over x, cancels with the other 1 over x, so this function is just x squared plus x. This looks like the domain should be all real numbers, so we need to be a little bit careful. If we had done this part first, we would have thought the domain was all real numbers. But since the function was formed by combining f and combining g, the old restriction still remains. So you have to be careful. The correct domain is this one. All right, let's do another example. Here, the domain of f is x has to be greater than or equal to 0 because we're taking a square root. Here, x can be any real number, so sometimes we write it like this. That e thing means that x is an element of, x is a real number. So, how do we combine these? What's the intersection? What rule satisfies both? Well, for the first one, x has to be greater than or equal to 0, so it has to be here. For the domain of g, we could take the entire number line, but where do they intersect? This part. So the domain of f plus g is x has to be greater than or equal to 0. And we could double check this by adding them. The domain of f plus g of x is just square root x plus absolute value of x. That domain, again, since there's a square root, has to be greater than or equal to 0. But be careful, just always compute it by first computing domain of f, then computing domain of g, and then combining the two restrictions. All right, I hope this helps. Good luck with the problems, and I'll see you next time.